Okay, welcome. So let's continue our discussion with the apply family of functions. And now I want to talk about some packages that we can use to help run some of these commands in parallel. So we talked about how we could use the par_l_apply function, which is going to run an lapply command in parallel. I'm working in Colab, so I've got two cores that I can use. So at most, I can run commands with two cores, so two parallel processes going on at the same time. There is another package called future.apply, and this is not installed in Colab, but you can. So I've already done this in the first code cell. So you may already have future apply installed and loaded. If you haven't run these commands, then you can run the install and library command to install and load future apply. But future apply works pretty similarly as it did with the parallel package. There are some functionality for different apply functions. For example, the lapply function that we can run in parallel. But the advantage of future.apply compared to parallel is that we can run these parallel processes either on a single local machine, a parallel set of local machines, or on a mix of local and remote machines. So this doesn't really apply to us because we're running this in Colab, which has two core, and they're both kind of like remotely in the same cloud. But if you were running this on your local computer in RStudio, that might make a difference. So what I need to do is set up a plan, and you can run !plan if you want some more details on that. But I first run a plan command, and I indicate how many processes I want to run, and I'm going to do them in multi-session approach. And again, you can run !plan if you want more details on this. I'm just trying to give a little informal discussion of parallel computing. But this means I'm going to set up two cores to run this same command, which is I'm going to run the sleep iterator function 6 times. So the function name from the future.apply package is I want to future_lapply. And then I pretty much enter the usual arguments for lapply. My data is 1 to 6. I'm going to run this 6 times, and the function that it's going to run is sleep for 1 second. And so if I run this, it should take about 3 seconds to run. I think the initial time it may take a little bit longer because it had to set up the core, but now when I run it, I think these should take 3 seconds. Yeah, so each of these is taking about 3 seconds to run, which makes sense because we set up two core. And the last package I want to talk about is the pbapply package, P being parallel. We won't see too much of a difference in this package compared to the others in Colab, but it runs much the same way. We need to set up how many core processes are we going to run at the same time using a similar command as using the make cluster command. So here we're going to set up two core. I've already run this command and stored it in the object CL, but this makes two clusters. And that's the most that I can use in Colab. If you haven't installed and loaded the pbapply package, then you would want to run this code cell, which installs and loads it because this is not already installed in Colab. But I've already installed and loaded the pbapply package. So now I'm going to run the pbapply pbapply function. So you can use this with different apply functions, but I'm going to run in parallel the lapply function. That's what this is doing. I'm going to run the sleep iterator 6 times. That's what that is saying. And here we need to specify how many core we have. So how many core processes are we going to run in parallel? And that was 2 for us. So this should take about 3 seconds to run, and it did. What's nice about this PB apply package is that if you're running this, for example, in our studio, it does create a little progress bar. So maybe that's what the PB stands for, progress bar, that keeps track of how much progress you're making to completing the command. So I'm going to go over and run some of these commands in RStudio just so you can see the difference of what it looks like in RStudio. Okay, so now I'm working in RStudio. I just have an R script file. So I've got R code over here. I'm looking at my console down below. I'll clean that up. So I've already installed these packages in my local RStudio, but I want to load these 3 packages that we just talked about in Colab. So that's the parallel, future.apply, and pbapply. You can see those packages were loaded. I can see my output in the console. So when I'm working in RStudio, I can kind of run separate codes at a time. I can just highlight what I want to run and then run that code. So there is a command, detect cores. This tells me that my computer that I'm running RStudio on right now has 8 cores available. Okay, so that's more than what I had available in Colab. I'm going to create that same sleep iterator function, which is just going to sleep for a second. So when I run sleep iterator, it's going to sleep for 1 second. I'm going to run this, which just creates that sleep iterator function. And then here we can check that if I run lapply 1.6 sleep iterator, it's going to go to sleep for 1 second and repeat that 6 times. So that should take about 6 seconds to run. And it is running. You can see the stop sign over there down below. And now you can see that took 6 seconds. Then I can go ahead and using the parallel package, I can set up 2 cores, run par lapply, which is going to run the lapply command in parallel with however many core I decide. So here I did 2. So this command is going to set up the core. Maybe I'll do them separately. And then I'm going to run the sleep iterator using 2 parallel processes. And this should take about 3 seconds to run. And that was great. On my computer, I've got access to more core. So I'm going to maybe set this up with 6 parallel processes. And now let me run this. And this should take about a second since it's doing it 6 times in parallel. And that took about a second. We could do similar stuff with here, this package is the future apply package. Let's say I want to set up 6 parallel processes here. And the function is future underscore lapply. But otherwise, this will work just the same. And we can run this, and this should also take about a second to run. Oh, I messed up because I did not highlight this last parentheses. Let me try that again. That gave me an error, right? So I'm going to run this again correctly with all of my parentheses. That took more time than I thought because I think it just had to set things up initially the first time. And now it's taking 2 seconds. So it did not do it as efficiently as the parallel package did it. Lastly, we can set up the progress bar lapply package. So we'll see that we'll get a little progress bar that's going to appear, and I'll do this 2 times so that it takes a little bit longer to run and we can actually see the progress bar. So now running this, it's going to run this in parallel 2 times. So it should take about 3 seconds in total to run if we're running it in parallel. And you can see down below, we had a little progress bar that was running that kept track of how we're doing. So if you're running something that's really long, it's nice to keep track of like how far along am I in this process. And that's what you get out of the PB package, the pbapply package. Okay, so that is a wrap on this module 15 that dealt with the apply functions. Thanks, everyone.